This is the software development process as part of your revision for a higher course. So let's start off by kind of setting the scene a little bit. We've got to know that the software development process is an iterative process, which means that at any point when you discover new information, perhaps at testing stage when you find errors, that you can go back and revisit any of the stages in the process. You've also got to know the names of the steps and preferably the names of them in the correct order. And one way to do that is to remember a dance in the dark every Monday. So hopefully that helps you to remember at least the first letters of all of these steps. Now the first step is the analysis step. Now you need to know several things here. You need to know that there are different groups involved in hashing out the software specification, and that is the client and the systems analyst. Now the client is the person that orders the piece of software or wants this piece of software created, and the systems analyst is the person who comes into the company. They'll discuss it with the client, they'll observe them using their current system, they'll read up on all the documentation, they will interview and survey the users of the current system to plan out ways to improve the current system. And when they've done this, they'll create the software specification, which explains exactly what the new piece of software's got to include. And it's important to remember it's a legally binding contract that tells you exactly the requirements of the piece of software. So after the analysis is completed, they'll then go about designing this piece of software. Now there's different approaches to design that we've missed here that you could do with reading on, and those are modular, stepwise refinement, top-down and bottom-up, and it's worth having a read of those because those are important as well. But you also need to know about ways of designing it. Now there's two graphical design notations, which is flowchart and structure diagram, which use different shaped boxes if it's a flowchart to show you the flow of data around your program, and a structure diagram is where it breaks down the main problem into smaller sets. You can start to visualize the different modules your system will require. And pseudocode, which is spelled incorrectly here because it should have a U, is an approach where you use numbered steps written in English. And again, stepwise refinement here is more apparent for us because we would usually start by writing down the main steps that our program's got to go through and go back and look at each of those and saying, is there a way to simplify this? After we've designed it, we then go on to implementing it, and the choices that they would have at this stage are what software, what language are we going to create it in, and we could choose from different ones like declarative, we could use scripting languages, event-driven or procedural languages, and those are something else you need to do a bit of reading on. This is very important for the exam. So after we've implemented it, we then need to test it. Now, there's three different types of test data you need to know about. So if we take an example where we're validating your day of birth, which could only be numbers from 1 all the way up to 31. Normal tests are where you test within the range of data that's allowable. So from 1 to 31 is allowable. So we don't test at the borders yet. Normal is within the range. So something like 5, 10, 15, 20, 23 are all normal tests. Extreme tests are where you test right at the boundaries of expected input. So in this case, it would be 1 and 31. And exceptional tests are where you test out with the boundaries of expected input. So minus 10, 100 letters are a good example of exceptional tests in that case. And when you have a test approach that's been planned out and it includes normal, extreme and exceptional tests, you can say that your program has been fully tested. As well as these types of tests, you need to know about approaches to testing or test plans. And the systematic one is the one you should be most familiar with because you should have done it for your coursework. And systematic testing is where you set out a test plan. So you would plan out the inputs you're going to input. You would write down what you expect your program to do in these situations. You carry out the test and you write down exactly what your computer system or what your piece of software did rather, and this would allow you to compare it to the software specification to say, does it match the requirements? Comprehensive testing is where you try and test your software as completely and as fully as possible, and that's helped in situations where you work in a design team and there's several programmers working on it. You can bring in independent test groups to use it like the end user. That's important to read up on as well, actually. And have modules where it means it's easier to test each part separately rather than the full system at once. Exhaustive testing, they'll tend to ask you why it's impossible, and it's impossible these days because of how large modern applications and modern software is in terms of millions of lines of code, and it's just impossible to test for every possible scenario and every input in every situation. If you think of games on Xbox Live and PlayStation and so on, they're always sending out updates to these software because they find glitches and bugs and so on in them. So after testing, we then move on to documentation. There's two types you need to know about. The technical guide is usually printed on the back of the box of software because you need to know all about the hardware and software requirements before you install it. So things like the RAM, minimum RAM capacity, the minimum processor speed, the operating system, the amount of backend storage, all the requirements, the technical requirements for your computer system are contained in the technical guide. And I tend to think the user guide's inside the box after you buy it, because once you install the software, you need to know how to install it and how to use it. And the user guide will tell you how to use the piece of software after it's been installed, what the buttons do, how to save, what the shortcuts are, and so on. After documentation, we then move on to the evaluation stage, and there's several other evaluations that's carried out. These are some of the main ones. Reliability and robustness, they'll tend to ask you what's the difference in between the two of them. And reliability is asking, does the program do what it's supposed to do regardless of how it's been designed? And robustness goes back to the validation and testing, particularly exceptional tests, where it checks that how well it copes with errors during the program being executed. If yours crashes when you type in strings, when your program expects integers, for instance, means your program's not very robust. User interface, looking at how easy the computer system or your program, is to use. Is it quite straightforward to use? Does it come with a help, for example? Maintainability and readability is an important one as well. Those are kind of linked. Maintainability goes back to how easy it is for our programs to update and maintain and understand your code. And readability is linked to that because readability is all about how easy it is for other people to understand your code. And there's several ways to improve the readability of your code if you have indentation, blank lines, internal commentary, modular code, good variable names. These are all things that make it easier for a programmer to understand what your code's trying to achieve. Fitness for purpose is an important one that's missing here, actually, where it basically asks the question of your software: does it do what it's supposed to do? Does it meet all of the things that's been suggested as part of the software specification? So these are all worth a little read because they're very important. So moving on to the final stage, which is maintenance. Hopefully you've been thinking a dance in the dark every Monday as we've been through this. There's 3 different important types of maintenance that you need to know and know the difference of. The first one, corrective maintenance, is where they try to fix any errors that weren't brought up at the testing stage, either by testing inputs in a test plan or using an independent test group to use it like they were the end users. So fixing any errors. Now that's something that the software development team could get themselves into bother for because it won't match the legal document, that software specification. So that's important to know that the corrective maintenance links back to software specification. Perfective maintenance is where this piece of software will be released and people, after using it for a time, will suggest ways to improve it. Now these probably or shouldn't or wouldn't be in the software specification because they're completely new ideas to make this piece of software even better than it already is. And finally, adaptive maintenance is where you would carry out maintenance or changes to your piece of software to allow it to run on different platforms, different operating systems, different computer systems with different hardware other than the ones it was originally designed for. Now that's a very quick overview of the software development process. There's several other parts that you need to go and read about the different roles that people have. We haven't spoken about the project manager who oversees this full project taking place, who's in charge of budget, who's in charge of timelines, in charge of staff, and making sure they're working to these deadlines. People like the software engineer, for example, as well, who might come out and install and maintain the networks that they're installed on. So there's a lot of reading if you want to get the depth of knowledge that you need to pass the exam and be successful here.